Alright, hi you guys and welcome. Today we will be definitely talking about this bad boy right here, which is solving a linear differential equation, okay? So standard form of the first order linear differential equations is you have to have dy dx out in front, and then it could be add or subtract, depends on what the number's next. Then some number right here, okay, this could be a constant, it could be a function of x, doesn't matter, but it has to be multiplied by y to the first. Okay, so that's the most important part. Alright, it cannot be y to the second or y to the third, it has to be y to the first. And then this part right here is just going to be a function as according to x. Alright, so to solve for the linear equation y prime plus p of x times y equals q of x. Okay, multiply both sides by the integrating factor v of x. Some people call it p of x, some people call it whatever. We're just going to call it v of x. And now this is going to be e, and this is all in the power. This is going to be the integral of p to the x, which is the same one right here. So the integral of this dx, okay, and integrate both sides. All right, so we're going to see how that works by working on this problem. All right, so we have our differential equation right here. Okay, now if you notice, we've got a lot of messiness, so we need to get it into this form. Okay, so first off, I'm going to divide everything by x, so I get dy dx alone. So dy dx equals x plus 3x, 3 over x, and then times y. Okay? Alright, so I divided everything by x just to get that out of the way. Now what I'm going to do is I'm going to minus the 3 over x times y to both sides, because now I'm going to have my functions all set up. So dy dx minus 3 over x y, or times y, equals x. Okay, so I have everything all set up to where I need to start finishing this. Okay, so now what I'm going to do is I'm going to recognize that this is my p of x, and I'm going to plug that in for the integrating factor. Okay, so the integrating factor is going to be v of x equals e to the, and then I'm going to do the integral. I'm probably just going to do a capital S to represent integral. Okay, capital S of, let me see, negative 3 divided by x dx. Okay, all right. Now as I work on this, this is going to be e to the negative 3, well, let's go parentheses, negative 3 natural log of the absolute value of x. Oops. Okay. All right. Now, by using the log rules, I'm going to bring this negative 3 to the exponent of x. So it's going to be e to the, and you'll see why in a second why I'm doing this, e to the natural log of x to the negative third. Okay. Now, because I'm putting the negative exponent up there, I don't need the absolute value any longer. Okay. And when this happens, these two bad boys are going to cancel out, and this gets brought back down to the bottom. So as a matter of fact, v of x is actually equaling 1 over x cubed. Okay, so the next step is multiply both sides by the integrating factor, and the integrating factor is 1 over x cubed. So that's pretty simple. So I'm going to multiply everything by that. So I'm going to get 1 over x cubed times dy slash dx minus, well, I'm just going to multiply it straight out. We all know what's going to happen. So you're distributing, so dy dx minus. Now, this was a confusing part to me when I first started doing this back in college, was I would distribute it and then I'd lose track of it. So keep it as in terms of its factors. So this would be 1 over x to the third times 3 over x times y. Okay. All right. Okay. And then we will have equals the other side, which is going to be 1 over x squared. Okay. All right. So I've already multiplied everything by it. Now this side I don't need as much because the product rule is what we're going to be looking at right here. Because if you notice right here, okay, the product rule, let me write it real fast. Okay, so the product rule of two things, and then you're integrating both sides, is going to be f prime of x times g of x and f of x times g of x. Okay, so if we keep the g of x right here, well, actually, if we keep the y, okay, as we work across this, you're going to see that the derivative is going to appear right here in both spots, and then the derivative is going to be right here in both spots. So that's actually really nice how this all sets up. Okay, all right. So now that I've got everything set up like this, I can move on to my next step, which is this. Okay. Now remember, the backwards version of this is just going to be setting up as the derivative. Okay. So now what I'm going to do is I'm going to do the integral of both sides, and when you do the integral of a derivative, it just becomes normal. Okay, so we just have 1 over x to the third times y equals negative 1 over x plus c. Okay, as we work across this. Now obviously I did forget the dx up here, so that's my bad. All right, but the cool thing is that you have everything pretty much all set up to actually just begin to solve this. All right, and when we simplify everything, okay, y is actually going to be equal to x to the third. Well, it should be just negative x squared, all right, plus c times x to the third. Okay, and this is going to be when x is greater than or equal or greater than 0. So you actually solved this for y, and you were able to actually work across it. So that's the really cool thing about using the standard form of the first order linear differential equation. Okay. Now the tough spot that a lot of students are going to have trouble with is this step right here. But if you keep it in terms of its factors, you'll be able to quickly see the two versions. It's actually just going to be the reverse of the product rule. Okay, so your y is usually going to be right in there, is going to be one of your functions. Okay, and then your x, you're just going to have to decide which one's the derivative of the other. And you'll begin to see this the more you practice this. Alright, so on this one, what we're going to be doing is we're going to be dividing everything by negative 3x. That's mainly to get this to be a positive y. Well, no, you're just going to divide by 3x. Okay, so what we're going to be left with is y prime minus 1 over 3x times y equals the natural log of x plus 1 divided by 3x. Okay. All right. Now this over here, this satisfies y of y input of 1 equals 2 is going to be our 2 points that we're going to get to actually find out what the constant is. So we're not just finding the general formula, but we're actually finding the actual formula. Okay. All right, so right now our p of x is actually going to be this. So let's find the integrating factor. All right, so we plug it in, we do the derivative, which is going to be the natural log of x, because remember we factor out this constant. Okay, all right, and then we bring this to this power, which gives us this right here, and then we get ex to the negative 1/3. So we're going to multiply everything by that, okay, which is going to turn into this. Okay, and if you remember, we're just going to do the reverse of the product rule here. Okay, and so we're going to have d over dx of, let me see, x to the negative 1/3 times y. Okay, oh, probably should have an extra set of parentheses in there. All right, and then we're going to do the integral on the other side, except we're going to have it as, let me see, 1/3 times the integral. All right, which it's going to look like this. Okay. All right, so when we do the integral of this side as well, obviously these two are just going to cancel out, and we're just left with this. Okay, it's amazingly enough, we are going to have to do the product rule. It's funny, we did the reverse of the product rule over here, and then we're going to have to do the product rule here and get this. Okay, but the cool thing is that we do have to solve for y, so we need to divide everything by x to the negative 1/3, and guess what? They all have x to the negative 1/3. So when I divide everything, I'm going to get y equals negative of the natural log of x plus 4. Okay, because I'm going to have to end up adding that in there. All right, plus c times x to the 1/3, okay, which is just going to turn just back into c. So I have everything all simplified down to this, and it's just a gorgeous problem in how it works. Okay. All right. Now, what we're going to do is we're going to plug in x at 1 and y at -2, okay, to find out what c is. Okay, and so when we plug in 1, obviously we remember the natural log of 1 is definitely going to be 0. Okay, and then this is just going to turn into -4, and then we're just going to add that to both sides. So c ends up to be 2. So we can go back to this original problem right here and go y equals the negative of the natural log of x plus 4 plus 2. And that was our original constant because we knew what the initial conditions were that satisfied it. Okay. All right, that's it. This is a particularly long process, but if you think reverse product rule and that you're going to multiply both sides by the integrating factor, you should be fine on working with linear differential equations. Okay. All right, that's it for today. I'll talk to you later. Bye.